All right, Module 25 starts with graphing a parabola again. So you guys have seen this before, but they just kind of throw in another little tricky part is with rational coefficients, and rational means fractions. Okay, so for example, we would have something like y equals 1/2 x squared minus 2x minus 4. Okay, the good news is that you can do it just how you've done before. So there's really two ways to go about it. I'll show you both. The way that I think might be preferable to you is if you remember that you can find the vertex, I should say the x-coordinate, okay, of the vertex by doing the opposite of b over 2a. Okay, so in our example, b is -2 and a is 1/2. So that means 2a is 2 times 1/2, which is just 1. Okay, so x will equal the opposite of b, which is +2, over 2a, which is 1, so it's just 2. Okay, and then remember, if you know x, you can find y. Y would be 1/2 x squared minus 2 times x minus 4. So we can go ahead and do that pretty easily, actually, also. 2 squared is 4. Half of 4 is 2. So 2 minus 4 minus 4, which is -6. Okay, so we have our vertex at 2, -6. All right. And then we can just remember, you just move out from the vertex to get some more points, and just be really careful when you plug them back in, because sometimes those fractions throw you off a little bit. It says I believe you can plot any 2 points you want. So if you want to stay away from fractions, if you use even numbers for x, right, then when you square it, you'll get an even number and you can cut it in half. Okay. So rather than doing 1 and 3 next, I would do 0 and 4. Okay. So if x equals 0, y equals, and that's going to be an easy one, right? 1/2 times 0 squared minus 2 times 0 minus 4, which is 4. So we have another point at 0, 4. We know from symmetry that we would have 4, 4 then also. Remember, with your parabola, if the vertex is 2, -6, okay, that's going to be, in this case, it opens up to the lowest point. So then if I know 0, did I just do that right? It's 0, -4, sorry. So if 0, -4 is on the parabola, okay, there's your line of symmetry, then 4, -4 also has to be. Okay, so I can get away without having to plug in 4. And then I would do another even number. Okay, so maybe I would do when x is 6. Okay, so y would equal 1/2 6 squared minus 2 times 6 minus 4. So that's going to be half of 36 minus 12 minus 4. So we'll have 18 minus 12 minus 4, which is 2. Okay. So then another point that I could have would be 6, 2. Okay, and then remember, again, because of symmetry, if 6, 2 is on the graph, the -2, 2 would also be on the graph. Okay, so they want you to do the vertex and then 2 points on either side. All right. I think that's probably the easiest way to do it. If you look in Alex, they have you completing the square. Okay, actually, they have you doing kind of some weird stuff. So go ahead. You could look at the Alex explanation, but I think this is going to be the easiest way for you. Okay. All right, and that's actually, they call that a chapter 3 topic, so it kind of goes back. But now we're going to get into graphing ellipses. Okay, ellipses are like your ovals. Okay, so let's kind of just do a little aside here. So a circle, remember, is x squared plus y squared equals r squared. Okay. An ellipse what we basically do is instead of x, it's x over a squared plus y squared over b squared equals 1. Okay, now let me go back to your equation of a circle. If I divide each term by r squared, I get x squared over r squared plus y squared over r squared equals 1. Okay, so if I were to write a circle using that, like if I did x squared over 16 plus y squared over 16 equals 1, then I could tell from that that it's a circle centered at 0, 0 with a radius of 4. So I would go centered at 0, 0, go 4 to the right, 4 to the left, 4, that was 4 up, 4 down, and I could go through those points and get my circle. Okay, with an ellipse, it's not the same. So maybe I'd have x squared over 25 plus y squared over 16 equals 1. Okay, so again, it's still centered at 0, 0, but kind of think of it as like two different radii. Okay, in the x direction, your radius is 5. It's the square root of 25. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In your y direction, your radius is 4. Okay, so when we do that, we get kind of more like this oval shape. Okay, it's an ellipse. So think of it as almost like a circle with two different radii, one in the x direction and one in the y direction. Okay, so we'll start with that little introduction there. Okay, before we move on to the next one. So the next one is graphing an ellipse. Oops. Given its equation in standard form. Okay, so the only thing that we're going to add to that example that I just kind of talked about is the center not always being at 0. Okay, so remember up here, we could change where the circle is by doing x minus h squared over r squared plus y minus k squared over r squared equals 1, and the center would be hk. Same thing with an ellipse. Okay, we could do x minus h squared over a squared plus y minus k squared over b squared equals 1, and the center would be at hk. Okay, so again, your standard form, x minus h squared over a squared plus y minus k squared over b squared equals 1, and we would have the center at hk. All right, and then we really don't, like, it's not technical to call it two different radii, okay? We would call it the major axis would be, I don't need that, 2a. It's kind of like, it's like a diameter. Okay. And then your minor axis would be 2b. Okay. Sometimes they switch it. A lot of times we want A to be greater than B. Okay, so if A is greater than B, your major axis is paired with your x's, then it's going to look like, well, here, your ellipse will be centered at HK. This will be a distance of A. This will be a distance of A. Okay, those are called your vertices. And then you have two more vertices here. And this distance would be B, and this distance would be B. Okay, if we have x minus h squared over b squared plus y minus k squared over b squared, a squared equals 1, that just means that it's going to be in the x direction, you have the smaller axis. So it would still be centered at hk. But then, going out to your 4 vertices here, this would be B, because B is with the x part. This would be B, this would be A, this would be A. Okay. Let me just see how they want you to graph it. I'm just seeing what the Alex tools want you to do here. Okay, I think we're good. All right, so they give us this example to do, okay, where we have x plus 2 squared over 16 plus y minus 2 squared over 36 equals 1. Okay, I wouldn't worry too much about, exactly like which one is A, which one is B. Is it the tall oval or is it the fat oval? Just start breaking it apart. So your center here would be at -2, +2. Because remember, it's the opposite. So if it says x plus 2, then it's -2. If it says y minus 2, then it's +2. Okay. And then in the x direction, from there, we're going to go 4. Okay, because we have the 16 in the denominator of your x term. The square root of 16 is 4. Okay, so from that center, we'll go left 4 and right 4. Okay, and then for our y direction, we want the square root of 36. So we'll go up 6 and down 6. Okay, so when we graph this, I can get my little graphing background on here. Okay, let me get myself a little bit more room. Oh, that's not good. Hold on. Hopefully, you know what? I'll go by 2s on my graph. Oh my gosh. Let me get that a little bit better. Okay. So going by 2s here. Okay, so the center is at -2, +2. So right there. Okay. And then in the x direction, I'm going to move 4 to the right, 4 to the left. In the y direction, I'm going to move up 6, down 6. And there is, oops, I moved. Yeah, I went too far there. That guy. Oops. 2, 4, 6 would take me there. Okay, so then that. Okay, so they want you to plot the center and then those, I think they want those 4 points. Okay, yeah, I think that's all that you need to graph there. Okay, all right, and we're going to graph a lot more ellipses here. So the next one, a little trickier. We want to graphing an ellipse centered at the origin. And it's going to be ax squared plus by squared equals c. Okay. So for this one, you have to keep in mind that it has to equal 1. Okay. So we can't have it equaling c. So for example, if we have 16x squared plus 9y squared equals 144. It can't equal 144. It has to equal 1. Okay, so we're going to divide all terms by 144. Okay, and let me give you a little hint here that you'll see a lot. 16 times 9 is 144. Okay, so we're going to get some stuff that reduces here. So if we divide by 144, we'll have 16x squared over 144 plus 9y squared over 144 equals 1. Okay, and because of this hint, we know we can reduce these. So 16 over 144, divide both by 16, reduce that fraction. So it's x squared over 9. And then for your y squared one, divide both the 9 by 9 and 144 by 9. Okay, it'll simplify down to something like that. If it doesn't, let me know and I'll help you with it. Okay, but I think you're going to make these work out to be pretty easy. All right, so this will be centered at 0, 0, and they already told you that. It's going to be centered at the origin. Okay, in the x direction, we want the square root of 9. So we'll go left, right, 3 from the center. Okay, under y, we've got 16. Square root of 16 is 4. So we'll go up, down, 4. Okay, so when we graph it, we are going to be at 0, 0. I'm going to go by 2's again. Okay, left, 3, right, 3, up, 4, down, 4. And there's your graph. Okay. And they should, like, here, let me just check another one here real quick. Yeah, they're gonna all simplify down real nice like that. Okay, so if you get any sort of weird numbers, call me over and I'll help you. All right. Okay, our next one is graphing an ellipse given its equation in general form. So you might remember we did this with circles earlier in the year. You had to complete the square twice. Okay, so we have 4x squared plus 9y squared plus 24x plus 72y plus 144 equals 0. Okay, so what we do, and just be really careful with your work here. Okay, so the first thing you do is you're going to group the x's together. And then you're going to group the y's together. Okay, and then you're going to do the plus 144 equals 0. Okay, so we've got our x's and we've got our y's. Okay, now this is a lot easier if it was just x squared and just y squared, but we have 4x squared and 9y squared. Okay, that's kind of your hint that it's not a circle, the fact that those coefficients are different. So we factor out a 4, and we're left with x squared plus 6x. And then we factor out a 9, so we're left with y squared plus 8y. And we just kind of ignore that 144 for now. Okay, so we factored it out. Okay, here I'm going to write to the side here. The first step that we did from here was group your x's and y's. Okay, then once we got to the next line of work, what we did is we factored out the coefficient. On your x squared and your y squared. Okay, now what we do is we complete the square. Okay, so remember you take half that middle term. So x squared plus 6x, we would have x plus 3 squared. Okay, now remember that will get our x squared plus 6x, but then it gives you extra, right? So we're going to have to subtract something off here. We'll figure that out in a second. Okay, by completing the square, we add in more values that we'll immediately subtract off. And then we're going to do the same thing. So half of 8 would be 4, so it'd be y plus 4 squared. Okay, so we got to subtract off whatever we added there. I've got too big of a gap there. Let me close that gap a little bit. Okay, so we'd have plus 144 minus the two numbers that we just added in. Okay, So I'm going to call it, if you're taking chemistry, you know what balancing the equation is? We're going to balance things out here. Okay, so if I expand this, I'd have x squared plus 6x plus 9. Okay, if I distribute that 4, I have 4x squared plus 24x plus 36. If you look back up here, I want 4x squared, I want 24x, but I don't need that 36. So that 36 is one of the things that I subtract out. Okay, the plus 36 here with the minus 36 here balances. Okay, I do the same thing with the y's. It'd be y squared plus 8y plus 16. Okay, and that would be 9y squared. Perfect, that's what I want up there. Plus 72y, awesome, I need a 72y, plus 144. Okay, so I need to subtract out a 144 here. Okay, so what I end up with is 4x plus 3 squared plus 9y plus 4 squared minus, because I have the 144 minus 144 works, so minus 36 equals 0. Okay, and then I'm going to get that 36 to the other side. So I'd say we're going to move our constant. Okay, and I'll give you a hint. First of all, it should always be positive on that other side. So it should always be negative on the left side, and then we add 36 to both sides. It should be positive. Okay, and then just like the last one that we did, you're going to find like it needs to be 1. Okay, so we're going to divide. And you're going to find, remember, 4 times 9 is 36. So it's going to simplify down real nice for us. Okay, so 4 times x plus 3 squared over 36 plus 9 times y plus 4 squared over 36 will equal 36 over 36, which is 1. And now we can simplify. So divide numerator and denominator by 4. And we have x plus 3 squared over 9. Now divide them both by 9, and we have y plus 4 squared over 4 equals 1. Okay, so now it's in our graphing form. Okay, so our center is at -3, -4. Okay, and then in the x direction, we move the square root of 9, which is 3. Okay, and in the y direction, we move the square root of 4, which is 2. So when we graph it, centered at -3, -4. Okay, in the x direction, we're going to move 3 to the right, 3 to the left, 2 up, 2 down, and there's our graph. Okay. All right, there are a lot of steps to that one, so don't be shy if you need help and ask, okay? All right, next one. We are finding the center, vertices, and foci of an ellipse. Okay, so we're good with center, we're good with vertices. What the heck is a foci though? Okay, so if we go back to your definition of a circle is all points that are the same distance away from one central point. Okay, so if you think about it, you could draw, if you use like a thumbtack. Okay, so imagine taking a tack with a piece of string on it, and you stick it to a cork board. Okay, if you were to stretch that string so it's taut, and maybe like tie it around a pencil and swing that pencil around. Think about like how a compass works. You draw a kind of a misshapen circle there. Okay. So the way that an ellipse works is think of taking two thumbtacks, okay, sticking them to the wall, draping string between them, okay, and then take a pencil and like use the pencil to tighten that string, okay, like kind of stretch it so it's taut, and then kind of move that pencil around, okay, and I can show you this in class too. That makes an ellipse, okay. Now remember, we already talked about, kind of looks like a smiley face, doesn't it? Yeah. I mean, think about like that taut piece of string. Okay. So like over here, the pencil's here. Okay. Way over here, the pencil's kind of stretching on top of itself. We're moving that pencil around. Okay. You could also find YouTube videos that kind of explain how to do this. Okay. We draw out that ellipse. Okay. And then we talked about this distance here is A. This distance here is A. This distance here is B. This distance here is B. Okay? Now, those 2 points where we thumbtacked our string, those are the foci. Okay? And this distance is what we would call C. Okay? Now, the kind of interesting thing here is that A squared equals B squared plus C squared. Okay, keep in mind A is always the bigger one. A is greater than B. All right, so we have this relationship that's almost like the Pythagorean theorem. Okay, excuse me. And it's kind of like how we actually like derive the formula for an ellipse, which we're not really going to worry about. All right, so I'll show you how to pick apart these pieces that you need. So if we are given the ellipse x minus 2 squared over 25 plus y plus 4 squared over 169 equals 1. Okay, first of all, you guys know that the center is at 2, negative 4. Okay, we know that we move left, right, 5. Okay, because that's the square root of 25. That's in the x. We move up and down the square root of 169, which is 13. Okay, so if we just kind of sketch this out, I'm not going to do like a nice, grid graph. The center's at 2, negative 4. I move left and right 5. So left 5 would be at negative 3, negative 4. Right 5 would put me at 7, negative 4. Okay, and then up, down. So from negative 4, if I move up 13, I'm at 2, 9. Okay, and if I move down 13, I'm at 2, negative 17. Okay, now Alex is only going to consider the farther one, the vertices. Singular is vertex. Okay, and I think technically the other ones are not considered vertices. Okay, I think it's just easier if you use that change interchangeably, but they're not. So our center would be at 2, negative 4. Okay, our vertices would be the ones that are farther away. So 2, 9 and 2, negative 17. Okay, so the last thing to do is find our foci. Okay, your foci are always in the same direction as the vertices. So in this one, they're going to be up and down also. All right, remember A and B are the square root of 25 and the square root of 169, but A is the bigger one. Okay, so A would be 13 and B would be 5. Okay, and then all you need to do is remember this relationship that I told you here. So a squared equals b squared plus c squared. So 169 equals 25 plus c squared. These are going to work out nice too. You're going to get 144 is c squared. So c is 12. Okay. So again, your foci are along that, what we call that major axis, the bigger one. Okay. And then rather than moving up and down 13, we're going to move up and down 12. Okay. So it's going to take us just one below. There's where your foci would be at 2, 8 and at 2, negative 16. Okay. All right. So there's the answers that you're going to put into Alex. Okay. All right. Moving on. Oh, lost my spot. The next one is finding the foci of an ellipse given its equation in general form. Okay, so we're going to go through our completing the square thing again. Okay, to figure out what A and B are. And then we're going to figure out what C is. Okay, so the example that they give us here is 25x squared plus 9y squared plus 100x minus 125 equals 0. So if you remember, the first thing we want to do is group our x's and y's. This one's a little bit different in that there is nothing to go with the y. We're not going to have to complete the square for it, so that's nice. Okay. We factor out the 25 from the x terms. Okay, we complete the square, but again, only with the x terms. That means that we just added in an extra value that we're going to cancel out over here. Okay, so we're going to check that. It'd be 25x squared plus 4x plus 4. So 25x squared plus 100x plus 100. Okay, so where we wanted 25x squared plus 100x, we have 25x squared plus 100x plus 100. So that means we have to subtract off a 100. Okay. All right. So now we have 25x plus 2 squared plus 9y squared minus 225 equals 0. And we're going to get that 225 to the other side. Oops. And again, they're going to make it easy for you here. We want to divide everything by 225. 25 times 9 is 225. Okay, so we're going to have 25x plus 2 squared over 225 plus 9y squared over 225 equals 1. 25 over 225 is 1 over 9. 9 over 225 will be 1 over 25 equals 1. Okay. So a couple things here. It would be centered at negative 2, 0. Since the bigger number is under y, it's going to be shaped like this. Okay. We will move. It's not asking for the vertices. Okay, so we don't have to really worry about the vertices at all. But know that the vertices would be up and down. So when you calculate C, your foci are also going to be up and down. Okay. So because the bigger number again is 25, A is 5, B is 3, and A squared, I don't know why I wrote that U there. Let me erase that. Okay, A squared is B squared plus C squared. So 25 is 9 plus C squared. It's going to work out nice for you. You're going to get used to all these square numbers, okay? C squared is 16, so C is 4. Okay, so from our center, we need to move up and down 4. Okay, so if we're at negative 2, 0, up 4 puts us at negative 2, 4. Down 4 puts you at negative 2, negative 4. Okay, so our foci are at negative 2, 4, and negative 2, negative 4. Okay. All right, next one is writing an equation of an ellipse given the center, an endpoint of an axis, and the length of the other axis. So it's kind of like the puzzle here of the other axis. They're giving you like pieces and you need to put it all together. Okay. So I would definitely like sketch it. Okay. Keep handy x minus h squared over a squared plus y minus k squared over b squared equals 1. And that one, remember, is going to be shaped like that. X minus h squared over b squared plus y minus k squared over a squared equals 1 is going to be shaped like that. And then remember, a squared equals b squared plus c squared. So definitely keep that handy when you're going through these. Okay. But this one says, in our example here, the center is at 0, negative 1. The minor axis has a length of 10. Okay, so remember, 2b then is 10. So b is 5. Okay, and one vertex at negative 7, negative 1. Okay, so start by kind of sketching this out. I'm going to go by 2's on my graph. The center, let me just get a different color here that might show up a little bit better. Okay, the center is at 0, negative 1. The minor axis has a length of 10. Okay, we'll go back to that in a second. One vertex is at negative 7, negative 1. Okay, and remember the vertex are those are the endpoints of the major axis. Okay, so this distance is 7. Okay, so that's A. The fact that they told us the vertex is always on the major axis. Okay, so A is 7, B is 5, because we figured that out up here. We would go up 5 and down 5. If we were trying to like sketch the whole thing, we could go right 7. Okay, so there would be the endpoints of your axes. Okay, we know that H is 0 and that K is negative 1 because that's where it's centered. Okay, and then we know that A squared equals B squared plus C squared. So 49 is 25 plus C squared. Okay, so C squared. Oh, we don't even need to find C. Never mind. It doesn't ask for the foci. It just asks for the equation. Okay, so that's it. We don't need those. Okay. we can just do our x minus h. So just x, right? H is 0. So x squared over the fact that your major axis is horizontal, okay? That means that your a squared will go under x. So 49, okay? And then y minus k. So y minus a -1, so y plus 1 squared over b squared equals 1. Okay? That's it. That's your equation. So use the information to put your puzzle together and then put your equation together. All right. Next one. This might be interesting. We have word problems using an ellipse. Word problems involving an ellipse. Okay, so in this one, all right, so it's like an architectural tunnel that's in the shape of an ellipse, okay, or half an ellipse. We have the arch of a bridge. So they give you this little drawing. Okay, and they say we've got an arch of a bridge is a half an ellipse or a semi-ellipse. Okay. They tell you the arch is 164 meters long. And has a height of 52 meters. So from the ground here is 52 meters. Okay. And then they tell you at point P, so some point farther out, the height is 11. Okay. And they want you to find this distance here. Okay. How far out it has to be from the center. Okay. All right. So let's do this one. First thing we're going to want to do is come up with an equation of our ellipse here. Okay. So we're just going to, the easiest thing to do, obviously, is this center is at 0, 0. Okay. So put a coordinate system on it. If that center is at 0, 0, think about this. Okay. This point would be at 0, 52. We'd want to split that 164 in half. So that would be at 82, 0 and negative 82, 0. Okay, so we can see that the major axis is horizontal. It's nice we made it centered at 0. So we can do x squared over 82 squared plus y squared over 52 squared is 1. And that's your equation, okay? You're going to get a calculator for this, all right? So we want to know at this point here, we don't know what x is. That's what we're trying to find, but y is 11, okay? So at the point, y is 11. So we can do x squared over 82 squared plus 11 squared over 52 squared equals 1. Okay. So we need to solve for x. And we're not going to type anything into our calculator until we're kind of farther along here. So we can do x squared over 82 squared would equal 1 minus 11 squared over 52 squared. Okay. That'll get the 11 over 52 part to the other side. Then we can multiply everything by 82 squared. Okay. And then we can square root it. So just be really careful using your calculator to get this answer. Break it into pieces, okay? Technically, x could also equal the negative square root of that. And we'll go back to the drawing here to show you. So first of all, think about, I worry about you guys typing this in your calculator. Think about if your answer makes sense, okay? First of all, this is not really to scale. If the height here is 52 and a height of 11 would be like way over here, okay? So we should be getting an answer like pretty close to 82. All right. We're pretty far to the right. There are 2 points though where y equals 11. There's this point here. There's also the point over on the left-hand side. Okay. So that's where you could possibly get two values here. All right. The actual answer on this one is x equals 80.14. Okay. And that definitely makes sense. It's really close to 82. All right. So it's not too bad. As long as you center it at 0, 0, it's not too tough. Just be really careful putting that in your calculator. Okay. All right. What do we got next? Okay. Now, the next thing we're going to do is hyperbolas. Okay. So hyperbolas are a little bit different, but a lot similar also. So your hyperbolas, okay, those are going to have an equation of x squared, over, let me just get that right. Okay. So they're going to have the x minus h squared over a squared, okay? But it's going to be minus y minus k squared over b squared equals 1, okay? When we do this, we get a weird shape. It's shaped like this. That's a hyperbola, okay? If we switch the order, so subtraction, the order matters. So if we had y minus k squared over a squared minus x minus h squared over b squared equals 1, then it would be shaped like this. Okay. Now, I'm going to add some stuff here. First of all, hyperbolas have asymptotes that kind of make an X shape through them like this. Okay. So they kind of hug those asymptotes. Okay. Where the asymptotes intersect, that's your HK. Okay. So it's actually not a point that's on the hyperbola. All right. Then what we would do here is your A. So you kind of, let me do one more thing here. We're going to make like a box. Okay. In the diagonals of the box, oops, sorry, I should be going through. Hold on. Okay, there's a couple things about the box. First of all, they go through right here and right here. Okay. And the diagonals of the box are your asymptotes. So they go from corner to corner. So the box here would go here, here. Kind of like this. Okay. And then when it's horizontal like that, when it's the top one, your A value, I'm going to just color code it. This is A. Okay, so from your center to the hyperbola, to one of the branches there. So this is also A. Okay. That's your distance A. And then you might guess that the other dimension here is B. I suppose I could draw it the other way. Okay. So the boxes are going to be a dimension 2a by 2b. So this would be 2b, would be that side of the box. And this would be 2a. Okay. And then we have the relationship here. We do have foci here. The foci here are in the middle of those branches. I'm kind of drawing them farther out there. But the distance from the center to the foci is c. Okay. And we'll have the relationship here that a squared plus b squared equals c squared. C is actually the longest one. Okay. So there's all the pieces of a hyperbola. All right. They're a little more confusing than ellipses, but it's the same idea. Like just get all your little pieces that you need. Okay. So we'll go through an example here. Okay. Get a different color. Give the example y squared over 25 minus x plus 4 squared over 4 equals 1. Okay, so let's start getting some pieces here. So first of all, we know that the center, since it's x plus 4, it'll be at -4, 0. Okay, since the y piece comes first, we know it's going to look like this. Okay. A always comes first. So we have the y squared over a squared, so a is 5. B is going to be 2. And then c squared will equal a squared plus b squared. And actually, they're not going to ask for c in the graph, but so c squared is 29. We don't really need that. Okay. They're not going to have you graph the I don't think they're going to ask you to graph the foci here. Let me double check. It doesn't look like it. Okay. All right. So what we do then, get your graph going. Okay. Our center is at -4, 0. Okay. A is 5. So remember, since it's shaped with it up and down, okay, A is going to go up and down because it's with your y. Okay. So the fact that y comes first in this expression, the y squared over 25 is first, that means that we're going to go up and down 5. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. That's going to be the vertex. Okay. Where basically these points right here. Okay. And then B is 2. So we're going to go to the right 2 and to the left 2. Okay. And what we're going to do there then is we can draw in our box. Okay. Right 2, left 2. Because under the X is the 4. Up 5, down 5, because under the y is the 5. And that's all from the center. Okay. So when you draw in those boxes, then we can get our asymptotes. So connect the corners. Okay, I'm actually I can't zoom out anymore. I can only zoom in. Okay. So connect those corners to get your asymptotes. Okay. And then we're ready to draw in our hyperbola. So it needs to go through this point and hug your asymptotes. Okay, go through this point and hug your asymptotes. Okay. I'm just going to check real quick to see what they might ask for. So they just want you to graph it. Yeah, I don't know how many things they actually need you to plot on here. It looks like if you can plot the center, the two vertices, and maybe these corners here. Okay, so just use, this would be at -2, 5, right? Just by counting your coordinates there. Okay, they might ask you for that, but I can help you if you need help on Alex getting it graphed. Okay, we're gonna do more. So just like with the ellipses, there's several different graphing ones here. The next one, graphing a hyperbola centered at the origin in the form ax squared plus by squared equals c. But obviously b will be negative, okay, because we need that subtraction there. Okay, so we'll have, for example, 16x squared minus 9y squared. This is almost the same as the ellipse one that we did. Okay, so remember we want to divide everything by 144 because it has to equal 1. So we'll have 16x squared over 144 minus 9y squared over 144 equals 1. And those we can reduce. So x squared over 9 minus y squared over 16 equals 1. Okay, now since x comes first, it's going to be shaped like this. Okay, it's going to be centered at 0, 0. We're going to go left, right, 3. We're going to go up, down, 4. Okay, again, because there's a 9 under the x part, square root it and get 3. That's how far left and right you go. Since there's a 16 under the y squared, we're going to go up and down square root of 16, which is 4. Okay, so let's start graphing. Center at the origin. We are going to go left 3. Start drawing your box. Up and down 4. Finish the box. Okay, since it's looking like this, we've got our vertices here. Okay, at 3, 0, negative 3, 0, we can connect our corners to get our asymptotes. Okay, and then we're ready to draw it in. So go through this point, hug the asymptotes, this point, hug the asymptotes. Okay. It seems like a lot to remember, but once you kind of get the hang of it, you'll be okay. It is a lot to remember, but then you do all these problems using the exact same thing over and over again. Okay. All right, next one, just like with ellipses, graphing a hyperbola given its equation in general form. Okay, so this is where we're going to be completing the square. Okay, so we're going to have 25x squared minus 9y squared plus 150x minus 36y minus 36 equals 0. All right, so we're going to group our x's. We're going to group our y's. We're going to kind of ignore that 36. We're going to factor out our coefficients. And that's going to be 6. Make sure we factor out a negative 9. So y squared, be careful, plus 4y. Okay. All right, so we'll have 25x plus 3 squared minus 9y plus 2 squared. And we got to figure out what we need to take care of there. Okay, so we'd have 25x squared plus 6x plus 9. So 25x squared plus 150x plus, let's see here, 9 times 25. I always think about quarters. Okay, if I have 4 quarters, I have $1. 8 quarters, I have $2. 9 quarters, I have $2.25. Okay, so I just added in $2.25, so I'm going to subtract out $2.25. Okay, and then over on the other side here, I have, excuse me, 9y squared plus 4y plus 4. Okay, and keep in mind that that's a negative 9. So negative 9y squared minus 36y minus 36. Okay, so here I put in a negative 36, so I'm going to subtract a negative 36, which means add 36. Okay, so I've got 25x plus 3 squared minus 9y plus 2 squared minus 225 equals 0. So I'm going to add the 225. And I'm going to divide everything by 225. And I'm going to reduce. Okay, now I'm going to graph it. Okay, so first of all, center at negative 3, negative 2. X plus 3, y plus 2, negative 3, negative 2. Okay, in the x direction, I'm going to move 3 to the right, 3 to the left. In the y direction, I'm going to move 5 up, 5 down. There we go. I'm going to connect my corners to get my asymptotes. Okay, and then I'm ready to graph my hyperbola. Since x is first, it's going to be shaped like this. So one vertex here, one vertex here, and hug the asymptotes. There you go. Okay. All right. Next, finding the center, vertices, foci, and asymptotes. Oh, I'm running out of room here. I have to get a new drawing. Let me see here. I'm gonna grab a new drawing for some reason. Seems like it doesn't want to let me. Oh, see, I must have been zoomed in way too much for some reason. Okay, finding the center, vertices, foci, and asymptotes of a hyperbola. Okay, so they're going to give us the equation x minus 1 squared over 25 minus y plus 9 squared over 9 equals 1. Okay, so let's start picking this apart. First of all, our center will be at 1, -9. Okay. I would definitely do a little sketch to the side, just a sketch. Okay. 1, -9 is the center. We know it's going to be left to right again because x comes first. So I could go right 5, 2, 3, 4, 5. You know what? I am going to draw it a little bit more to scale for you guys because it's going to bother me too. Might as well do it right. It's going to help you get the answer easier too. Okay. Oh man, that's not the best axis there. Okay. So anyways, 1, -9. There's your center. All right, now we're going to go right 5. Left 5. Okay, up 3. Down 3. Okay. So our vertices are going to be here and here. Okay, so that's going to be, if this is 1, -9, 5 to the right would put me at 6, -9. 5 to the left would put me at -4, -9. So our vertices are going to be at -4, -9, and 6, -9. Okay. Then your foci are going to be next. Okay. So A would be 5, B would be 3, C squared is A squared plus B squared. So C squared is 25 plus 9, which is 34. So C would be the square root of 34. So that's kind of the first not nice number we've seen. Okay. So from the center, we would go left and right square root of 34. Okay. Square root of 34, that's going to be just under 6, right? So it's going to take us further than the 5. Remember, the foci are beyond the vertices for hyperbolas. It doesn't really matter on the graph. Okay. It's going to be about there, which would be, for an x, it'd be 1 plus the square root of 34, -9. And then in the other direction, we would do 1 minus the square root of 34, -9. Okay, so that's just from the center, moving left and right. Okay, so we would have 1 minus the square root of 34, -9, and 1 plus the square root of 34, -9. Okay, now the next thing they want you to do is the equation of the asymptotes, which is honestly kind of mean, I think. It's a lot, okay? But it's I guess it's not going to be terrible. Okay, so remember, your asymptotes go through here and here. Okay, so there's 2 of them. So for your asymptotes, they are both lines through the point 1, -9. Okay, one of them has a slope of up 3 over 5. Okay, so 3/5. And the other one has a slope of down 3 over 5. Okay, so it's always going to be like that. Okay, where they're opposites of each other. And it's always going to be using the A and the B. Okay, so if you remember your point slope form of a line, we can do y minus -9 equals 3/5 x minus 1, and y minus -9 equals -3/5 x minus 1. Okay, so y would equal, distribute your 3/5, 3/5 x minus 3/5. This would be a plus 9, so subtract 9. Over here, we'd have y equals negative 3/5 x plus 3/5 minus 9. Okay, so now we just need a common denominator so that we can add these guys together. So y equals 3/5 x minus 3/5 minus 45/5. So that'd be 3/5 x minus 48/5. And this one would be y equals negative 3/5 x plus 3/5 minus 45/5. So y equals negative 3/5 x minus 42/5. Okay, so there's your two asymptotes. All right, so your asymptotes be that y equals 3/5 x minus 48/5 and y equals negative 3/5 x minus 42/5. Okay, so again, there's a lot going on there. Okay, so just be real careful. Take your time. You'll get it. Let me know if you need help, though. Next one. We have finding the foci of a hyperbola given its equation in general form. Okay, so just the foci. All right. So we'd have 4x squared minus y squared plus 8x minus 12 equals 0. Okay, so again, we're going to complete the square. And just like the previous example we did with ellipses, we don't have to worry about the y. Okay, so we would group 4x squared plus 8x minus y squared minus 12 equals 0. We'd factor out that 4. And we'd complete that square. Okay, and that means that we have to subtract something off. So we'll figure it out. We'd have 4 times x squared plus 2x plus 1. So 4x squared plus 8x plus 4. So it's a 4 that we need to get rid of there. Okay, so I'm actually going to move to the right here. So then we'd have 4x plus 1 squared minus y squared minus 16 equals 0. So 4x plus 1 squared minus y squared equals 16. Divide everything by 16. And reduce. Okay, again, it's going to be shaped like this. Okay, the center will be at negative 1, 0. We'll go left, right, 2. We'll go up, down, 4. And that's not even really going to matter here. Okay, so your center is at negative 1, 0. And all we need to know is that the foci are going to be to the left and the right because it's shaped like this. Okay, so remember, c squared is a squared plus b squared. A squared is 4, b squared is 16. So c squared is 20. So c is the square root of 20. I'm pretty sure Alex is going to want you to simplify that to be the square root of 4 times the square root of 5, which would be 2 square root of 5. So we're going to move left and right 2 square root of 5. Okay, so your foci will be at negative 1 minus 2 root 5, 0, and negative 1 plus 2 root 5, 0. Okay. All right, next one. We have writing an equation of a hyperbola given the foci and vertices. Okay, so we have the foci at 8, -5, and 12, -5. We have the vertices at 9, -5, and 11, -5. Okay, so it's always a good idea to kind of sketch that out. Just a sketch. Okay, so 8, -5, and way over here, 12, -5. There's your foci. Okay. The vertices are at 9, -5. Ooh, I'm running out of room here. Let's do... Okay. I'm going to do the vertices using red. So the vertices are going to be at 9, -5 and 11, -5. Okay, which means we're shaped like this. Ooh, that's not quite. Okay. So it means that we're going to have our x squared, first. I'll just write that, x squared first. So it'll be x squared minus y squared to get that shape to it. Okay. It means the center, if I just kind of figure out, let's see, halfway between 9 and 11 has to be at 10. Okay. It's got to be, your center has to be halfway between the foci, halfway between the vertices. So the center would be at 10, -5. Okay. A would be 1, right? Because from the center, we go left 1 and right 1 to get to our vertices. C would be 2, because from the center, we go left 2 and right 2. Okay. And then remember, C squared equals A squared plus B squared. So 4 equals 1 plus B squared. So B squared would equal 3. And we don't really need to figure out that B is the square root of 3 because our equation uses just B squared. Okay. We also know that A goes with X, right? So X squared is going to be first, and that's going to have the A with it. So we'll have X minus 10 squared over that A squared, which is just 1. And you can put the 1 there. Minus Y minus -5, so Y plus 5 squared over B squared equals 1. Okay. And again, don't be shy. If you want me to kind of check these a little bit before you put the answers in, I'd be happy to do that for you. All right. Next one. We're getting there. I promise. Writing an equation of a hyperbola given the foci and the asymptotes. And they say this is basic, so I think they're going to be kind of like a little bit easier problems here. Okay, and again, it's going to help you if you can kind of sketch these out. All right, so we've got our foci at -10, 0, and 10, 0. And we have our asymptotes at y equals 1/7 x and y equals -1/7 x. Okay, so I think what might make these easy is that they're going to be centered on the y-axis. Okay, but we'll see. So we can draw in our foci at negative, not to scale here, -10, 0, and 10, 0. Okay, so again, that means that we're going to be shaped like this. Okay, And that also means that C is 10. Okay. And then our asymptotes 1/7 x and -1/7 x. So the slope is 1/7. So go up 1 and over 7. Oh, I forgot I'm not really drawing it to scale. Okay. And then like this. Okay. Now, what that means then, remember, is that that horizontal distance is A. Okay, so A would be 7 and B would be 1. Okay. The fact that we go left and right 7 and up and down 1 to basically like connect those corners. Okay. And that's your B and that's your A. Okay. Whatever's with the Y is how far up you go, the rise, and whatever's with the X would be how far left and right you go. Okay. Hold on a second. Because something's not right. Oh boy. They're going to make this a little bit trickier for you than I thought. Oh boy. Okay. So, what the problem here is that this doesn't work. Okay, because a squared plus b squared is supposed to equal c squared. And that would be 49 plus 1 equals 100. And it doesn't, right? Okay, so what we need to do instead is, I need to think here for a second how I want to explain this. Because it's not, give me a second here. So basically, the B to A has to be 1 over 7. Shoot. I'm going to pause my video here quick. Okay, I apologize. My whole family just came home and I knew they were going to be loud. All right, so back to what we were doing. Okay, this doesn't work. You could check it first, see if it works. If it does work, you're in good shape. Okay, but remember the slope is just a ratio. So 1 over 7 is B over A. Okay, so if you cross multiply, A has to be 7B. Okay, which means that A squared has to equal 49B squared. So going back to what we had over here, A squared plus B squared, excuse me, needs to equal 100, which means 49B squared plus B squared has to equal 100. Okay, just replacing that A squared with 49B squared. So 50B squared has to equal 100. So B squared is 2. Okay. So that's kind of an important trick here. Okay, again, if it were going the other way, then the slope would be A over B. Okay, this slope is B over A when it goes like this. When it goes like this, the slope is A over B. Okay, so let's just remember that. So if B squared is 2, then A squared is 49 times B squared, which would be 49 times 2, which is 98. Okay, so that definitely makes things a little trickier. All right. Again, don't be shy about asking for help. Okay. The good news is we're done now. So the center is at 0, 0. Okay. A squared is 98. B squared is 2. So we would have x squared over 98 minus y squared over 2 will equal 1. Okay. All right. Last one then. We have a parabola one. So we've got graphing a parabola of the form y equals ax squared plus bx plus c with rational coefficients. So this is, for some reason, just a repeat of what we just did at the very beginning. Graphing a parabola of the form. Yeah, we just did this. So see the first topic. Okay, and then we're done. So there's a lot in this module, so just make sure to ask for help if you're struggling.